Alright, solve each equation with that calculator. Before we start these, let's look at the notes from the Exponents manual. From page 21 of your Exponents manual, found on the rubric page of the Canvas, on page 21, we have solving exponential equations. So to get rid of an exponent, you log b each side to get rid of those. Solving logarithmic equations, you want to base both sides by the base of log. So in this case, we would b both sides, base both sides by b, and then you would just have what's left inside the log to have a linear equation. Now, somewhere on your page, go ahead and write down the definition of a logarithm, these properties right here. To get rid of a base, we log b. To get rid of a log, we base b. Okay, let's look at number 112. So we have log negative 2k equals log negative 4k minus 10. That's the common log, and the common log's base is 10. So we're going to base 10 each side to get rid of those logs. So then you have negative 2k equals negative 4k minus 10. And that's just a linear equation that we can solve. So add 4k to each side. So then we have 2k equals negative 10. Divide each side by 2, and then you have k equals negative 5. Now, before you say that that is the answer, you need to plug it back in and see if you get a real answer. So negative 2 times negative 5 is a positive 10, so that will work. Negative 5 times negative 4 is 20. 20 minus 10 is 10. So that's the same thing. If you ever got a negative inside of a logarithm while you're checking your answers, that would be an extraneous solution, and you would not include that as your solution. You would write that and note that it's extraneous, though. Let's look at another one. Solve each equation. Round your answers to the nearest 10,000th. That's going to be 4 decimals. So let's look at number 124. 13 to the 2n plus 10 equals 17. First, we will isolate the exponential part. The exponential term is now going to be isolated. So 13 to the 2n equals 7. To get rid of the base, we're going to log each side, log 13. Log 13. So those cancel out. You have 2n equals log base 13 of 7. Divide each side by 2. And then you have n equals log 13 of 7 all over 2. And then you would plug that into the calculator. So we have log base 13 of 7 all over 2. And that would equal 0.3793. If you solved it with logs, you could also have an exact answer of ln 7 all over 2 ln 13. Both of those would be acceptable exact answers. And then here's your approximate answer. Let's look at number 131. 2 plus log base 5 of negative 10k minus 7 equals 2. So from here we're going to isolate the log first. So then we have log base 5 of negative 10k minus 7 equals 0. To get rid of the log 5, we're going to base 5 each side. 5 to 0 power is 1. So we have negative 10k minus 7 equals 1. Okay, let's isolate the variable. So negative 10k equals 8. Divide each side by negative 10. So k equals 8 tenths reduces to 4/5. So we have negative 4/5. Now before we set that's the answer, we need to check to see if this is a positive number. So this is going to be a positive number. It's 10 divided by 5 is 2. Negative 2 times negative 4 is positive 8. 8 minus 7 is positive, so that's a real solution. Again, if you get a negative number inside of log where you're checking your answers, that would be an extraneous solution. Let's look at one more question in this section. Condense then solve each equation. Round your answers to the nearest 10,000. That's 4 decimal places. So we have log 9 of 6 minus log 9 of 5x equals 2. We're going to use our division property. So then we have log base 9 of 6 divided by 5x equals 2. To get rid of the log, we're going to base each side by 9. So then we have 6 over 5x equals 9 squared, which is 81. Okay, let's cross multiply. 6 equals 405x. Divide each side by 405. And then we get x equals 6 over 405. Which is approximately 0.0148. Now if you plug that into the original, you get a positive number inside of all the logs, so that is a real solution. Try the rest of these on your own for solving. Show some steps, and then check to see if your answer is accurate from the key. And then move on to the last section. Exponential logarithmic word problems.